energy, but that is off campus. They have taken something like 25, 30 variation depending on their success in their exams. Then there is sorry boys, that was director on the line, and he wants details about which companies are coming for campus interview, because now I think higher authorities are continuously monitoring what is the placements that are happening. Placements are happening on the basis of vacancies, and number two, on the basis of availability. And there is a third element also on the competency of the students. So these are the three factors. Number one is the vacancy, number two is the availability, and number three is the competency and caliber of the students that are available. So right now the situation is very bad. One thing is the pandemic has caused a lot of issues in reducing the number of intakes. This has happened with everybody. Shipping Corporation of India used to take 40 to 50 boys every year, but now they have their own institution where they are training boys. They are getting earning money also from there, and they have their own students. This is going to happen with all major companies. All major companies will have their own institutions which will be arranging for engineering cadets. And that is why they have stopped taking from our institution or any other institution. Situation is very, very tight. And unbelievably, this year we have got 266 boys in the first year. I don't know where the jobs are going to come. But one benefit you have is that your degree is a graduate degree. So you are eligible for appearing for anything even outside the shipping. Some boys appear for gate. If they appear for gate, it means they are capable of sitting for any technical offer that is available in the market. It is not necessarily shipping. Right now, shipping is in a very bad state because of this damn pandemic, because of getting seafarers off the ship and getting seafarers on the ship. But let us see, NYK has still responded, and I have sent them the CVs of all the 36 candidates along with the list. And now, any day, he had told me by the end of this week, he will respond. So today is the 9th. So by 12th, we expect some response from them regarding dates of online tests and interviews. The only tricky part is that your semester exams is also going to start during this period. And if it happens, I don't know what to do, frankly, because I do not want to keep requesting them to make changes. That reflects very poorly because NYK Shipping is already making their schedules to interview candidates from various institutes. One is Tolani, one is Amity, and maybe IMU Chennai also. So Kolkata is one of them. Now, if Kolkata starts making requests, please postpone it, please post, they'll get disgusted. So under no circumstances, I want to hear any complaint from boys for the online tests that NYK will be asking you to attend. You might have to attend the semester exams in the morning, and in the afternoon, you will have to attend the interviews. So be prepared on that level.
Sir, we have our exams in the afternoon.
Okay, then it might be in the morning. I will tell him that they are having exams in the afternoon, so you take it in the morning. So you be prepared for both sides, for possible interviews from NYK and at the same time examination. One thing is I can do is not allow it to overlap. So you'll have to forego one of them. That is not possible. So you might have the interview in the morning and exams in the afternoon. So that is the possibility. So don't ask me to request them to postpone whatever plans they make. At the most, I can tell them change it from afternoon to morning. That's all. I don't want to keep making requests and pleading to them to change. They get ultimately disgusted. He said, what schedules we put up? Yes, Ravi Prakash, if you want to say something.
Sir, about the examination, sir.
Ah.
So, like my current financial situations are not very good to purchase one laptop, and he was like, and they are not even allowing considering the mobile phone. Like
no, you're not. You're not going to be allowed to use a mobile phone because it cannot be proctored. That's again a new word that have come through the university. Proctored means, you see, some person will be designated to monitor 20 students, and those 20 students will be available on the screen so that he can see you. and it'll be an online test. So most of the time you'll be focused looking at your screen. If there are long answer questions, you will be writing out the answers on the paper with him visible. And if he finds that you are possibly using unfair means, he can cancel your paper. And then after that, there is no request to be upheld. So there is no option, but you have to be visible on the screen. Otherwise, you cannot sit for the exam. You cannot say it is expensive and all that. No way. Because the situation is such, you have to use online procedures. And online procedures means sitting for exams also. So that is the way it is. If you can't sit for the exam, you will be kept aside till there is a chance for having proper examinations in the college. And when you will be called in the college, nobody knows. They have said 28th February, but I doubt it. I doubt it very much. See, there was a time when I told your senior batch, don't worry, by 2nd of June, you will all be called back. This is what I told them in end of March and April when the lockdown has just started. I had thought by 2nd June, everything will be over and all the boys will get back. June, July, August, September, October, November, December, January, February is gone. And still none of us are being called back for normal regular duties. So I just don't know when it is going to happen. It could become July. So that is why if you have to sit for the exam, sit with the online exam. If you cannot sit, IMU will say, okay, don't sit now, you sit later. Then you will get delayed by 1 year. Further 1 year. As it is, everything is delayed. Then you are going to ask for excuses. We will sanction your excuses. IMU will be glad. They will never say no to you. So they will sanction your excuses. You sit for the exam later when you are able to sit in the examination hall in DMET with a paper and pencil. By that time, you will see all others have finished their examination. Results have been declared. They have already submitted their results to the shipping companies, and you're still behind. So you take your chances. IMU will allow you. Okay, you cannot sit for the online test, don't sit. You sit for the exams when it is available with paper and pencil. Okay, that is going to be the case. So you have to be smart, somehow, somewhere manage. You have to manage. There is no way you can get out with it. So we were on page 9. So let us go to page 9. Yeah, this is page 8, this is page 9. Okay. So what one page before, we were describing that instrument, indicator card taking instrument, and I have already explained to you through a diagram, and that diagram was given as I put this special plate to give you a diagram which you can actually use for your examination if it is asked for. Sketch and describe a indicator card taking instrument. Next, they will ask you, what is the care and upkeep of such an instrument? So you'll have to say that we need to clean this passage where exhaust gases come. We have to clean it with a cloth and then lubricate that passage, ensure that the link points are also lubricated so there is no stiffness during its functioning. And we also ensure that the coil spring inside is not stretched when it is kept in place so that everything is kept in order. It has to be kept clean inside a designated box which is like a jewelry box. And apart from the instrument, you have other fittings which are listed in that paper. Spanner, then you have a spare springs. You have springs, different scale springs. Then you have scales. Then you have a lubricating oil can. So these are all the parts which should be there in that box. After 5-6 years, some of the parts are missing, as usual. So that is one thing you have to be careful about. And this is the diagram which you will possibly be asked to draw. So I have simplified the diagram as much as I can. And then I made it in a way that you can draw. I don't expect you to draw a diagram like this. This is not very self-explanatory. More self-explanatory is a sectional view of the piston area showing the piston rings and the spring. So the springs are under compression stress here. Now to describe it, I have given some statements, which is as what we shall read through. Description of the internal of the indicator card taking instrument. It is made up of a small piston of a known size which operates in a cylinder against a specially calibrated spring. A magnified linkage with stylus transfers the piston movement to a drum on which is mounted a piece of paper or card. Let's look at the diagram again. So you have a spring here and you have a linkage which magnifies the movement of the stylus. That means if the piston moves 1 to 1.5 centimeters, this will move about 7.5 centimeters, almost 3 inches. So this linkage provides for that magnification and also provides for the stylus to move in a vertical direction. If this linkage was a simple linkage directly connected, it would move in the form of an arc. This arc movement would not be a straight line. So that is why this linkage is a little special to enable this point to move absolutely vertically. And on the drum, you have a clip on which the paper is fitted, and the ends of the paper pass through these wire clips and pulled tight. So the paper is tightly fitted onto the drum. Okay. The drum oscillates. That means it rotates backwards and forwards under the pull of the cord. The cord is moved by a piston link rod. No questions yet. So this, what you see here, the drum, it has got a wheel over here with a cord around it. And this cord is passed over a pulley and pulled downwards. This pulley, it can be shifted. It can be rotated around the drum depending on convenience of the indicator cock position and that piston link mechanism. So to move that entire pulley, you have a butterfly nut. This butterfly nut is intended for your finger operation only. You don't need a spanner. So this nut can be loosened and this plate, what you see, can be allowed to rotate relative to the drum. And once the pulley position is finalized, that is convenient so that the thread goes directly above the piston mechanism. This thread has to go directly above. Then you tighten this nut. And then this cord, what you see, is put as a loop over this piston link mechanism. So right now, when the piston moves up and down, this link also moves in synchronized motion with the piston. So that means this cord is being pulled in synchronized movement of the piston. In other words, the drum is rotating based on the piston movement. All right. But the gas pressure which is acting on the piston here is moving the stylus based on the variation of the gas pressure here. It is not that the stylus is moving uniformly from top to bottom and bottom to top. There is a difference in the movement and in the rate of movement because the gas pressure inside the combustion chamber is a varying pressure. This variation in pressure is also felt on top of this piston. And this variation of this pressure will give a varied movement of the scriber. So the rotation of the drum is as per the piston movement and the movement of the scriber is as per the variation of the gas pressure. All right. So these two are combined to give you a diagram on the paper. Okay. The drum oscillates. It rotates back and forth. The cord is moved by a piston link rod. A line diagram is etched when the stylus is pressed against the paper held on the drum. See, the moment the piston is moving up and down, the drum is also rotating back and forth. Okay. Then what you do with this handle, you turn so this spindle, this link mechanism can be rotated. Moment it is rotated, it goes and makes contact with the stylus on the paper which is on the drum. And this has to be only momentary because the movement is very fast, reasonably fast. You just touch and let go and immediately close the indicator cock. You cannot afford to keep the indicator cock open for too long because the heat from the exhaust gases will make this part very hot. In fact, it has become so hot you can't touch it with your bare hands. You have to wear gloves. So what we do, we wear gloves on only one hand, and the other hand, we need to operate this lever and it gives you a better hold, a better feeling, a better sensitivity towards operating this instrument. To hold that instrument, that hot instrument, you will need to wear at least one glove. Moment the diagram is drawn on the drum, you need to pull the scriber off from that paper. Otherwise, what will happen? It will keep going over that line repeatedly, and ultimately it will make a very thick line, or it will cut that paper. That paper will get torn. So it has to be very gentle, very quick, and immediately close the indicator cock. So this whole card taking program or process of the diagram coming on the paper should not take you more than 3 to 5 seconds. That is definite without fail. So is there any difference between BMW engine or Sulzer engine? Hey, that's a very, very wide question. Is there any difference between BMW engine or Sulzer engine? Of course, there is world of a difference in their construction, in their details. But if you say, is there any difference in their functions? No, there is no difference in their function. But constructively, they are definitely different. BMW engines will be using the Bosch type of pumps. Sulzer engines will be using the Sulzer type of pumps. So there are a lot of differences between the two engines. Constructively, minor details, pipelines, everything will be different. The design of the piston, design of the combustion chamber, everything will be different. Okay. So this variation, the differences will be definitely there. But if you're saying, is there any difference in taking the pressure cards? There is no difference. There is no difference. The principle is the same. What happens in the combustion chamber in a two-stroke engine is the same in Sulzer, BMW, Gota Worken, or any two-stroke engine. It is the same. The gas pressures will rise, gas will be released. That will be the same. And again, the instrument arrangement may be a little different, but the principle is the same. They will be also having a drum, they will be taking a pressure because it is a two-stroke engine. It will be linked to that rod over here. And it may not be a rod, it might be an angular lever which is moving. So these are the differences. Mechanically, the design might be different, but in principle, it is the same where it comes to taking indicator cards. Does it answer your question, Jaiswal? Kshitij Jaiswal is not replying. Okay, so let's move on. What we have is now the stylus. This is the description of what happens while taking the diagram. The stylus draws out an indicator diagram which represents the gas pressure on the engine piston at different points of the stroke. And the area of the indicator diagram produced represents the power developed in the particular cylinder. I'm not going to allow this boy to come in, whoever it is. Let's see who it is. Because he's come too late. Nilesh Kumar. It's almost 10 o'clock, 9:55. If I allow 5-10 minutes, it's okay. But after that, you become a disturbance. So the stylus draws out an indicator diagram which represents the gas pressure on the engine piston at different points of the stroke. That's why I told you the gas pressure which acts on the piston gives a varying movement of the stylus or the scriber. But the rotary movement of the drum is identical to the movement of the piston. Combining these two, you have the diagram. All right. Because the stroke movement has to be shown, and within the stroke, what is the variation of the gas pressure inside the cylinder has to be shown. And this can be shown by that indicator diagram. Okay. The cylinder power can be measured if the scaling factors. Scaling factors means all the scales of measurement. The scaling factors, spring calibration, and some basic engine details are known. That means diameter of the piston, stroke of the piston, RPM of the piston. These are used for calculating the power. Okay. The cylinder power values are compared, and for balanced loading should be the same for all units. Ultimately, once we calculate the power from each, we may require to adjust the fuel pumps of some of them to make sure that all the units are giving the same power or near about the same power. It is not always possible to get the exact power from each unit. 1, 2, or maybe 5, 6 bhp differences will be there. And this is maybe because of the resistance to movement of the piston, resistance, or the quality of one injector from another. Slight differences will be there. So the combustion process may be marginally different from each other. So there will be a marginal difference in the powers of all the units. But within 5%, if all are within that range of power, it is considered a balanced engine. Balancing is of two forms. One is mechanical balancing, where the inertia forces arising have to be balanced. That is the mechanical parts, and that we discussed already earlier. And the second one is power balancing. Power balancing means getting equal power from all the units. And this can be done by adjusting fuel pump settings or can settings, whatever is required, to ensure that the balance from each of the units is more or less the same. Okay, the cylinder power values are compared, and for balance loading should be all the same for all the units. Adjustments may be made to the fuel supply in order to balance the cylinder loads. See, you need to power balance, because if you do not have power balancing, then what happens? The stressing of the engine will be unbalanced. Some part will be more stress, some part will be less stress. Then this differential stressing limits will cause fatigue failure. So that is why you need to have power balancing as an important arrangement. Next, now we are coming into the diagrams. The instrument can give four useful types of diagrams to show four different conditions within the engine. There is a fifth one, which I don't find on board the ship of any relevance, and they don't ask us also on the ship. But it is there in theoretical books, in theoretical papers, in theoretical statements, etc. So we will consider only the four important ones, and they are: number one, power card, and this is also called indicator card. The other ones are also card, but they are not directly called indicator card. They are called draw card. This draw card is also called an out of phase diagram. Out of phase diagram means, see, what pressure is indicated on the diagram is at a different moment as compared to the position of the piston. All right. The diagram that comes on the paper is at a different moment as compared to the position of the piston. In other words, the piston is always 90 degrees ahead of that diagram. If the piston is at TDC, this diagram position is shown 90 degrees before TDC. And when the piston is 90 degrees after TDC, this diagram will show the position at 90 degrees. So it is 90 degrees out of phase. So that is why it is called an out of phase diagram. Okay. So second one is the compression diagram. This compression diagram is to show what is the compression pressure inside the cylinder being built up by that particular unit. And this is achieved by cutting off the fuel so that there is no combustion. There is no injection of fuel which will cause combustion. So what you get is only the compression pressure and expansion pressure. So whatever compresses, that is the pressure that is red and shown in the diagram. So only the compression pressure is checked. But it is also very important to check the compression pressure, because it is ultimately indicating to you the integrity of that combustion chamber, that there is no leakage. If the piston rings were bad, if the piston rings were leaking, then the compression pressure would not be very high, it would be low. If the compression pressure is low, then the peak pressure is also very low. Your quality of combustion is also very poor. Everything suffers based on poor compression pressure. It is not only piston rings that could be leaking. It could be the gasket of the cylinder head also leaking. It could be some of the mountings which are fitted are not properly seated, so they are leaking past the air starting valve, the relief valve, the injector, the indicator cock is another source for leakage. So ultimately, this compression diagram is intended to check the integrity of the combustion spaces, whether there is any leakage or not. Okay. Number four, what we have is a light or weak spring diagram. This, when you take this diagram, you are required to change that spring on the indicator instrument and replace it with the weaker spring. This spring allows the piston inside to move to its end limit. After that, it will not go anymore. But this also helps in identifying what is the condition at the end of the indicator diagram. Let's have a word here. Okay, let me first, no, there's no diagram here. So I will show you the diagram just now. So this light spring diagram, first let me tell you the beginning part, that it is replaced with a very soft spring. And that soft spring helps to identify the conditions at the lower end of the stroke. That means during exhaust, during scavenging, and that's all. Because the spring is soft, it does not allow the piston to move beyond its limit. And the spring has to be changed and is a dedicated spring for this particular diagram only. For the power card, draw card, and compression diagram, you use the same spring. But for the number four, light or weak spring, you use a different spring. Okay. A fifth diagram is also taken, is called pressure derivative diagram. And it is supposed to tell you what is happening at different parts of the stroke, at what time. But that can be seen in your draw card also. But I don't find it of any relative. The entire process is shown in your pressure derivative diagram. I don't have much information on this, so I will not try to give you also. But there is such a thing called pressure derivative diagram, which I have never used on the ship, and I can't give you absolute data on its requirements. It's not required on the ship. It is required only on paper. So that is it.
सर
Yes.
सर जैसे हम लोगों ने स्टार्ट किया ये इंडिकेटर इंस्ट्रूमेंट से हम लोगों ने डायग्राम लेना स्टार्ट किया
हाँ.
तो वो तो इंस्टेंटली हीट अप नहीं हो जाता है
Of course, heat up hota hai. But the point is, you have to be very quick. That is why it requires a little caliber. Open the indicator cock, take the diagram, close the indicator cock.
लाइक
The
सर इट वुड
ground,
टेक सम टाइम ना टू लाइक अगर
no,
वो
no, no,
इंस्ट्रूमेंट
no, it will
हीट
not
होने में
take
कुछ
time.
टाइम तो लगेगा
Maximum 3 to 4 strokes of the piston. Maximum. Maybe
तो
2 to
फिर
3
उसमें
is ideal.
जो इनिशियल टाइम में जो स्प्रिंग होगा उसका तो टेम्परेचर अलग होगा और जो फाइनली जब हम लोग निकाल रहे होंगे उस समय का टेम्परेचर तो अलग होगा
No,
और
no, 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 no. The spring will get heated up, but you have to take it very quickly. This whole thing gets heated up. And the heating is how much? 80 degrees, 70, 80 degrees centigrade. So it is hot to touch, but you will still have to hold the instrument. This part of the instrument gets hottest. This part does not get so hot because this is the place where the exhaust gas is coming. And the exhaust gas quantity is very small. You see, the diameter of that piston is the diameter of your thumb. And the piston rings are similar to the rings that you wear on your fingers. It is so small. Okay. So the quantum of heat coming is also very small because the quantity of air gas coming is small. If it was a big one, then the quantity of heat coming in would also be very much. Then the whole thing would have got heated very fast. But it is very small, but very accurate. And the passage from the indicator cock has to be very clear. So each time there is compression pressure, it acts on top of this piston. All right. There is no leakage. There is no leakage. So the valves at this side, and the top of the piston are the only places where it will get heated, because that's where the exhaust gas is. Exhaust gas is not coming on the link, but the heat through conduction of the metal parts will cause this also to be heated up. All right? Have you understood?
Got it.
Okay. So where were we? We were on, sorry. Yeah. So we were on this one. So the light spring diagram takes the diagram at the lower end of the stroke, which means the exhaust, the scavenging, the return from BDC, and the pressurize, that part of the diagram is taken by the light spring diagram. Along with this instrument inside that box which stays with chief engineer, it is like a jewelry box. The inside is lined with felt, soft cloth, similar to what you see in your jewelry boxes. And there are compartments made with the instrument to be based and supported over there. Apart from that, there is place for keeping the spare springs. There is a place to keep the scales. There is a place to keep the spanner, and there is place to keep a bottle of lubricating oil. And of course, there is a cleaning brush. So the items which are there with the thing are scales and matching assorted springs. Sometimes you have 2 to 3 springs, but usually 2 springs are enough. One is for the light spring diagram, and one is for the other 3 diagrams: power card, drop card, compression diagram, all 3. That is common for all 3. Okay. There's a special paper booklet. That booklet is similar to your checkbook. Your checkbook, everybody has seen a checkbook. So the papers inside, it will be slightly smaller than the checkbook, if I remember correctly. A checkbook is a little too big. It will be a little smaller, maybe 1 centimeter less on either sides. Okay. So this booklet of special paper means it's really special. It is a little stiff, and on the surface you have a white coating. The paper itself is a maroon or a red colored paper, and on the surface is a white coating. So if you have a scratching device like a scriber or a pointer, you can make a mark on that paper, and that is what makes the diagram. There is no pencil or pen used. It is scratching on the paper that gives the diagram. And you have to be a little careful in handling it, because if your fingers are oily, it will make patches on that paper, and ultimately those paper diagrams you have to send to the office. So your caliber and competency is seen on how neat and tidy you are in making out these diagrams, because these diagrams have to be dispatched to office. And if they see a messy diagram, they will say this second engineer or chief engineer is no good. He is very clumsy. A marine engineer has to be very precise minded. He has to be technically competent in handling instruments, machines, tools, everything. That is why we work with our hands. You have to be very good with your hands, and better than some of the technicians who come, because technicians are purely practical in the sense, if it breaks, they will fix it. Why it has broken, what is the solution, they don't think on those levels. You as an engineer, you will have to think on those levels, and also do a better job than him when it comes to repairing, fixing, or taking care of that particular instrument. You have to be more than your subordinates when it comes to any work in the engine room, practically as well as theoretically. If you are good in your work, believe me, you will be a king on the ship. Even the chief engineer will have a lot of respect for you. But you have to be very good and sincere. I have seen junior engineers, they command so much of respect because they are genuinely very good, very sincere in their work. And sure enough, chief engineers, very, very dependent on them. So when they give them a job, he knows for sure that that work will be done without a flaw. If you can bring about that kind of confidence in your senior engineers, your life is set, not only on the ship, even after ship. He will give you a very good recommendation, and wherever you go, those recommendations will make a big difference. But ultimately, you have to earn that recommendation from your senior engineers by being very good in your work very efficient, very responsible. All right. So these are the items that you see inside that jewelry box which contains the instrument. Okay, let's go on to our next diagram. Now the power card, I have further details on this diagram. So, but right now this is still an introduction to the cards. The first one is called the power card. When you draw that power card with the help of that piston link pulling on that cord and rotating the drum, it is purely a mechanical process of drawing the diagram. You don't need much of talent here. You need to be only quick and precise in the sense quickly open the indicator cock, get the diagram, close the indicator cock. The drum can keep rotating as many times, it doesn't matter. But the duration for which the indicator cock is kept open has to be limited. Open quickly, take the card, close the indicator, and then close it tight. So now no more heating. Then you can take out that cord from that loop. You can take out that paper from that drum and have a look at it after opening it out and see the diagram has come like this, what you see. This is the diagram that comes out with the cord attached to the piston link. This is the indicator card, and this card is used to calculate the power of that unit. See that scriber which it moves along this side when the piston is moving up. It moves, that is the compression line. As it compresses from here, the firing starts and the peak pressure rises, and thereafter the piston starts coming down. So this line becomes the expansion line. As it keeps expanding, it comes to a point where the exhaust port or exhaust valve opens, and then there is a sudden drop in pressure down to the atmospheric level. Then again, after air comes into the system, compression starts, and then it goes up again. So when you press the scriber onto the paper, it has to be momentary. Within that momentary, the whole card will be drawn. So that is why that indicator cock has to be opened only for a short while. The scriber has to be pressed momentarily and the indicator cock to be closed immediately. All right. Then you can remove the cord from that link, take out the paper and move on. Next is the draw card. This is the draw card, the same procedure as the power card, but the cord will not be attached to that piston link mechanism. After you fit the indicator card, you fit the paper in place, you open the indicator cock, pull the cord, close the indicator cock. At the same, of course, one thing you have to press the scriber on it, pull the cord, and then close the indicator cock. Get it? Open the indicator cock. Press the scriber onto the thing. Initially, the scriber will be moving only up and down. And within that movement, you pull one time. So it will come. Actually, I could have drawn few vertical lines over here. It would have made a little more sense because as soon as you open the indicator cock and before you can pull the cord, there will be lines over here because you have to press the scriber before pulling the cord. So the moment you pull the cord, you get a diagram like this. And then you release the scriber from the paper, close the indicator cock. Then take out the paper from the drum and spread it out and see how neat your diagram has come. This is the diagram that will take some amount of practice. And sometimes you get messy diagram. So once you know the speed at which you have to pull the cord, it will become automatic to you. Then next time when you do it, you will pull at the same speed. It will not be too quick. It will not be too slow. That is that you will get. It
Sir,
is, yes.
sir, do we have to a specific regarding crank angle when we put the scriber, when we press the scriber?
Sorry, I couldn't understand your question.
Do we have to be a specific regarding crank angle when we press the scriber?
No. You cannot. It is not possible. You will have to take your chances. Maybe 3-4 times you'll get one card good. First time when you do it. Then next time maybe twice you'll have to do it. First time doesn't come well. Okay, you take another one. There is no dearth of papers on board the ship. There is no restriction to the number of cards you use. I have seen 12, 14 cards being wasted on one diagram because when You have a guy who cannot draw. When I told second engineer, okay, try and take a diagram, he couldn't. So I told him, take again. He couldn't. Again, I told him. About 10, 12 cards later, he was able to get a proper card. Then again, the second time when I told him, take the card, 5, 6 times, 5, 6 papers were wasted, and then he got the card. But ultimately, you have to learn. Doesn't matter if there is some wastage of cards or papers. But once you get the knack of it, you become an expert and you feel good about it. So this draw card is the difficult one to take. The other cards are very simple to take. This is the only one that takes a little practice and your sense of timing, how much you will pull when the scriber is pressed against it. Then again, you will have to do two things simultaneously. Press the scriber and pull the cord. Now you cannot keep the scriber pressed in position. Then what will happen? You will keep getting vertical lines over here. And that vertical lines will immediately cut off that paper. It might tear the paper. So you have to be very gentle and then remove wood and at the same time pull the cord. Pulling the cord is not a difficult job. You can pull it to the end position. So you will know where is the end position. So there is no issue about pulling it only partially. It requires a little practice. I wish this instrument we had in our workshop, so we could have at least done some sort of practical training. This is where you need practical training. Okay, so this is your draw card, and this indicates the instant when the fuel is injected and the rate of rise in pressure up to the peak pressure. It gives you a reading where you can measure up to the peak pressure. And the difference from the atmospheric line to the highest point on the diagram is indicative of the peak pressure. And the indication up to the point where the ignition starts is indicated of the compression pressure. Both these values can be read by means of a scale. And this scale comes with the instrument. And this scale matches or correlates with the spring that is being used. So when you put the scale directly on the paper, you can measure directly compression pressure 40, peak pressure 90. So you get the reading directly. All right. So this is what your draw card is about. You can measure your peak pressure, you can measure your compression pressure. In the indicator diagram, you can measure only the peak pressure. There's no compression pressure that you can measure over here. So this is your draw card and this is your power card or indicator card. These two cards are the cards that are taken most of the time. About 85 to 90% of the cards taken on board are these two cards. The lesser number of cards which are taken is the compression pressure. Now, why is lesser? Why is it lesser? See, when we take this indicator card and draw card, we are actually calculating the power. So for about half an hour to 45 minutes, we run the engine at its maximum. All right, at the maximum. Maximum meaning higher CSR, 90%. Normally, if you run within 85, we are running at 90%. I mean, the ideal best we are running at, not MCR, not MCR. The ideal best at 90% load. Okay. Now, at that time, we don't want to change anything, any parameter on the engine. So that is the time the fifth engineer is told, take all the readings fresh, not for the logbook, but for this. So suppose we start at 11:30. So by the clock, exactly by the second, we take that RPM meter. The RPM meter is recorded exactly at that time. Simultaneously, we will take the fuel consumption meter in and out, both. Okay, so we know the position. Then all the other parameters are taken: cooling water temperature, exhaust gas temperature, cylinder jacket cooling water, all the other parameters are taken. I will give you a list when we are taking this. I have still to type it out, and all these are taken. So that is the time you cannot take compression card. Why? Because you have to cut off the fuel. Moment you cut off the fuel of one unit, the entire power development by the engine will reduce by that unit. So your ultimate calculations will go haywire. So we do not take this compression card when we are taking indicator card and draw card and calculating the power of the engine. We take it on a different occasion when we are not calculating the power of the engine. We take it on an occasion where we are only going to check the condition of the integrity of the combustion chamber. All right. So that is why this compression card is taken on a separate occasion, not during the occasion we take indicator card or draw cards. So during this compression card, what all we do is cut off the fuel and check the compression. Now I have shown you two diagrams here. One is like a mountain and one is a straight line. The straight line is link connected, with the link connected to that piston link. So what happens is the pressure goes up, pressure comes down. It is the same thing what happens on the power card, but because fuel injection is not given, because there is no combustion, because there is no work done, the line is a straight line. Otherwise, it is similar to this what you see in the power card. In the power card, because work is done, you get an area enclosed by the expansion and compression lines. Over here, expansion and compression is the same line. All right. So that is why no work is done and no fuel is injected. So this is a straight line. Similarly, the draw card, I have pulled the cord, and because there is fuel injection, there is a rise in pressure. But in this case, there is no fuel injection. So I just pulled the cord and I've got it like this. So there is no change in the pressure other than the maximum compression pressure. Are you able to understand, Jaiswal, about the compression card?
Yes.
Okay, okay.
No, sir. No, sir.
So these, what no, sir? Who is saying
Sir,
no, sir?
sir, regarding the
Yeah,
compression card.
okay. The compression card is taken with the fuel cut off. That means there is no peak pressure. There is only compression pressure. That means what the piston compresses is again piston going down. So the pressure reached in the combustion chamber will be up to the maximum compression pressure. So what you see in the diagram, there are actually two diagrams here. One is with the drum in rotation, because that cord is fixed to that piston link mechanism. So the drum is rotating. I press the stylus. Of course, I open the indicator cock, and that indicator cock that time will not give so much of heat because there is no combustion. There is only compression pressure, and that compression pressure is recorded by this straight line. What is being compressed is again expanding. What is being compressed is again expanding. Of course, we try to avoid too many times the stylus going over it because it might cut the paper. So just one or two times is enough. And this is a line shown during compression and expansion. Now, if I remove that cord and during a stroke, I pull the cord much like what I did from my draw card, I will get a diagram like this, because there is no fuel injection, no combustion, no peak pressure. There is only compression pressure. So you will get a mountain like this. And this value from the atmospheric line to the top of that hill or top of the point over here is the compression pressure. And this must tally with all the other units as being equal compression pressure. Now, is it clear?
Yes, sir.
Okay. The last one, what we have here is called the weak or light spring diagram. See, the spring is then changed. Okay. And then we have the diagram fixed with the cord, again with the piston link. So when it moves, this is the expanding, this last part of it, what is coming here. You see this point when it drops, this pressure drop. What happens here? It is shown over here. This drop over here is shown by this line here. This is the point where EVO means exhaust valve opens. It could have been exhaust port opens also. It need not necessarily be only exhaust valve. It can be exhaust port also. So the moment the port opens, the pressure drops, the exhausting takes place, and it keeps dropping till a point where the inlet port also opens. And remember, the piston is moving from the left side to the right side. The piston movement is on a horizontal plane, and as the exhaust pressures keep going out, up to a point where the inlet port also opens. That means the scavenge ports. The moment the scavenge port opens, the piston is still going down. Piston will keep going down till it goes up to BDC. But then the pressure inside the chamber will rise because the scavenge pressure will be coming in and it will be pushing out the exhaust gases during that period. And moment the piston reaches the BDC, then there is a certain momentum of the air. It goes in and little bit of it does not go in. So there is a little pressure drop over here. From this pressure to this pressure, there is a slight drop because there is a stoppage in the flow of air into the cylinder. That is why you have a loop over here at the end. Then the piston starts moving up and the air starts going. It does not really compress because your inlet port and exhaust port both are open. So the piston keeps moving out without any compression. After it closes the inlet port, some of the pressure and air escapes from the exhaust port. After it closes the exhaust port, then the compression starts. And then from this line, your compression starts. Now, if your exhaust port was choked, what would happen? Then this gas would not go out completely. It would come down up to a certain level, then it will continue here only, and then again start expanding here. It will never go right down up to the inlet port where the pressure drops almost to atmospheric. So this is because the exhaust ports are choked. So exhausting will not take place completely. It will come up to here and again then compression will take place. So part of that exhaust will have some amount of residual gas. Okay. Similarly, if your inlet port is choked, then the air pressure will not rise up to this. It will be much lower here. It will come up to this point and then again start compressing. So this is indicative of how good the air or the exhaust gas is able to get out and how well the inlet air is able to come in. So those readings are taken from here with the relative positions being shown at this point where the pressure drop suddenly takes place because the exhaust valve opens. Similarly, at the point where the inlet port opens, the pressure starts rising. And then you have the BDC where the piston changes its direction of movement and starts compressing the air. So these are the four relevant cards that you have in diagnosing the fault within the engine, to understand the power development in the engine, and also understand the breathing process of the engine. Okay, let me have a sip of water. I have written the statements that you will be required to write. Yeah, the power card. It is called an in-phase diagram. This is taken with the indicator drum rotation in phase with the piston movement. I've already told you what it means. That means the piston movement is synchronized with the drum movement. So the area within the diagram, that diagram which you saw, area within the diagram represents the work done during the cycle to scale, because you're using a spring of a certain scale, you're using a piston of a fixed diameter, and the gas pressure acting on it will move the spring to a certain level. All right. This may be used to calculate the power developed or mean indicated pressure in the cylinder. Okay. It is very simple. You find the area of the diagram and divide it by the length of the diagram, and you will get the mean indicated pressure. And then that mean indicated pressure you multiply with a cylinder constant plus multiplied by the area of the diagram and the mean effective pressure. Anyway, that will come to it. But it is ultimately this particular diagram is used to calculate the power of that cylinder. Peak pressure may be measured to scale between atmospheric line and highest point on the diagram. So from the atmospheric line and the highest point on the diagram will give you the peak pressure. And that is also measured by means of a scale. Okay. The cord must be attached to the piston link rod while taking this diagram. I told you that cord, you make a little loop on it, and that loop has to be passed over that piston link mechanism. So that cord is continuously pulled to cause rotation of the drum. This length of cord from that link to the drum is very critical, and it, only you get it through trial and error. Rahul Kumar has got a question. Sir, the engine is vibrating continuously and sometimes ship rolls and pitches. So does it affect the graph? Good question. Same question asked to me by another, the previous section, section A. And see, when you take these diagrams, the ship must be in calm waters, absolutely calm waters. There should be no rolling, no pitching, should be only calm. We never do this during bad weather. We never do this when the ship is pitching or when it's rolling, because that time the power output from the engine is not steady. The power output from the engine has to be steady to take measurements. If the power output is fluctuating, why will it fluctuate? If the propeller keeps coming up and down, out of the water, in the water when the ship is pitching, then sometimes the power is too much, sometimes the power is too little. So under those circumstances, we do not take power cards. We take power cards, draw cards, etc. only when there is calm sea. There's not a ripple on the water. And believe me, sometimes out at sea, everybody thinks sea is very rough. There are times when the sea is like a glass, absolutely like a glass. There's not a ripple. The only ripple that is being made is by the ship. Then you look out, there's a lot of ripples after the ship. But there are times when you get the sea is like glass, plain, no ripple, no wind. There are times like that, and those are ideal times. But of course, you don't get that very often. Mostly you get a calm sea, and that is the best time to take the indicator cards. Otherwise, in a rough sea, no, I'm getting tired. So, Rahul, does that answer your question? No, no, engine vibration is nothing much. Engine vibration will, it is not vibrating. There is a, you feel it, it's like a rumble. Do you feel yourself inside the car vibrating? You don't, but you can feel the rumble. Same thing with the main engines. But the engine vibration can't be avoided. Engine vibration is not damaging, it is not deterrent to any activity on the engine. It is not a deterrent to taking indicator cards. Engine vibration is there. In fact, more than the vibration will the pulse be of the fuel injection duk, 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 from all of them. But that is not a cause for worry. The engine vibration is not so intense. I think in my previous lectures, I have been talking a lot about vibrations and critical speed. So it has probably gone into your head that the whole engine is in a state of absolute vibrating and you are holding on to it wherever you go. It's not that bad. It is not that bad. It is definitely much smoother. But vibration is there, but nothing so damaging. If vibration was the level what you're thinking of, then every day there would be fatigue failure. Every day there will be fatigue failure. That is not what happens. It is not so bad. Okay. Okay. Uh, the area within the diagram, okay. Peak pressure may be measured to scale between the atmospheric line and the highest point on the diagram. The cord must be attached to the piston rod while taking this diagram. I think that is reasonably clear. Any other question, definitely ask. Now, Rahul Kumar has cleared one concept, that vibration that we've been talking about in previous classes is nothing to be scared about or worried about. It is there, but it becomes a routine. And it is not deterrent to any activity on the ship. It is not deterrent to activity like taking indicator cards. More than the vibration is the pulse of the fuel being injected. That is more distinct to the ears. And if you wear earmuffs, and make sure you have earmuffs, you won't hear much of sound. That's it. And it is not so difficult to take a thing. Next is power card. Now we are going, first we'll deal with the power card, then we'll go on to the draw cards. Now, in continuation of what we were describing about the power card, you had the compression line, and then you have the expansion line. And the area between these two lines is the work done. Okay. Now, first thing we need to do is measure the area inside this card. And this area can be measured by several methods. One is your Simpson's rule. If you remember Simpson rule, Simpson rule, mid-ordinate rule. And apart from this, you can use a graph paper. The graph paper will have little squares, and you sum total the number of squares inside that area of that diagram, you can tell the work done. But normally calculating the area under a curve or in a contained curvaceous area is a difficult prospect. So one is mid-ordinate rule, second one is using a graph paper, and the third one is the one that we use on board, and that is called use of a planimeter. Planimeter is also an instrument which goes together with the indicator card instrument. They come together in a way because one is intended for the other and one is useless without the other. It's like that. So this planimeter is also in a jewelry box and it is kept in the chief engineer's cabin, and it is his custody, his domain, his upkeep that ensures that instrument is not damaged. It's also a very delicate instrument, and let's read it before I explain any further. It is given here. The area can be measured by an instrument known as a planimeter or by the use of mid-ordinate rule. You can't use mid-ordinate rule on board the ship. On modern engines, this diagram can be continuously taken up by employing two transducers, one pressure transducer in the combustion space and the other timing sequence transducer on the shaft. Through the computer, we can thus get the indicated diagram and power of all the cylinders. Very simple. You fit one sensor on the combustion chamber and send the sensor signal to the computer. Computer has got its master controller, device, etc., algorithms, etc. And then another signal is required to tell you the timing. In other words, the position of the piston when the pressure is of a certain variation. So these two informations which are fed to the computer will directly interpret it into a diagram which will be available on your screen. Not only the diagram will be available, at the press of a button, it will also tell you how much power is being developed. Very simple, very easy. So that is why we don't need engineers on board. You see, and that is something, it is so advanced, so technical. We don't need engineers on board. These instruments can tell us whether and directly that diagram, that power can be relayed through Wi-Fi directly to the ship, to the ship's shipping office. And in the office, you have the superintendent who's sitting in front of his laptop and he's getting all the data. And he knows his ship is running fine. So where do we need engineers? So that is why it is frowned upon having ultra-modern ships. And it is one of the drawbacks to have ultra-modern ships where the number of seafarers are being reduced. There are ships which have already been tried out without any personnel. There is a ship which about 10-12 years back from Yokohama, Japan, it has sailed all the way across the Atlantic to Los Angeles, Long Beach. Los Angeles is there only. Long Beach, and no crew members at all. Cargo ship with cargo. What happens is in Yokohama, the pilot and the captain, they come on board and they, through their automation, maneuver the ship out of the harbor and bring it close to the sea. Then the helicopter comes, lands on the ship, they put it on fully automatic. The pilot and the captain both get on the helicopter, come back on shore in Japan. And the ship is left to proceed towards Long Beach, USA. So 12 days or 14 days, whatever it takes, it crosses the Atlantic. And then at Long Beach, another helicopter comes, lands on the ship, brings the captain and the pilot on board. So then they guide the ship into the harbor, and that's done. Then, after all, shore staff take over to operate the hatches. They come to the engine room, check everything. The data logger, trend monitor, all the devices, do the cleaning of the filters, whatever routine maintenance is required, they do it after every 2 weeks. We don't need any engineers on board. We don't need any crew members on board. Nothing. So those are the very ultra-modern ships. But IMO had put down his foot, saying that these ships are also hazardous. If something goes wrong, there's nothing you can do. We cannot fly a helicopter across the Atlantic. Then another ship has to come to rescue it. So there are ills with ultra-modern vessels, because then our, what are the seafarers going to do? That is the next question. If you don't have any occupation, it's going to be very damaging to society. So this is one of the reasons where too much of modernization is little frowned upon. I hope you understand the substitute to indicator diagrams. Here you are. You have a sensor on the combustion chamber and a sensor on the crankshaft to identify that particular unit's position, relative position of the piston in relation to the gas pressure of that cylinder. Using these two data, you can immediately get. If you want the draw card fuel injection also, you need to fit another sensor on the fuel injecting pipe from the pump to the plunger with a pulse sensor. That pulse sensor is so accurate, it will sense the beginning of the pulse, the mid stroke of the pulse, and end of the pulse. That means when the fuel has started to inject, how, at what rate it is injecting, and at what point it is completing. These sensors are so advanced. That sensor is also fitted. And next, you can have the draw card also showing you the complete injection process. So these are sensors which are very advanced, and they can be substituted for the indicator diagrams. But till today, indicator diagrams are still relevant and they are still being used. And they are also being used in your examinations at MMD, because there they have still not come into the area of asking you questions with computer diagnosis of indicator diagrams or computerized means of assessing power. They don't ask questions on that. So you need to continue with this. And I have given you some prior information also of other means besides indicator diagram, the modern methods. Okay. So through the computer, we can get the line indicator diagram power of all cylinders. Get online indicator diagram and power of all the cylinders. Oh, this is the same diagram which I had earlier and the way it is taken. That was all about the power card. This is taken with the drum rotation in phase. You have understood how it is taken. Next is the draw card. This is also called out of phase diagram. This is the card that is taken without the cord being looped onto that piston link mechanism. The cord has to be pulled by hand, and it is taken similar to power card, but with indicator drum 90 degrees out of phase with the piston stroke. You don't have to do anything. The drum movement records the condition inside the combustion chamber with the piston 90 degrees out of phase. That means piston will always be a little ahead of what is shown on the drum by 90 degrees, which is a fraction of a second, maybe a second or fraction of a second timing difference. Because when you pull the drum, the effect it is felt is exactly 90 degrees out. How it is 90 degrees, not 91 or 89, I don't know. But it is 90 degrees out of phase. Okay. The cord is pulled manually by the engineer while pressing the stylus against the card on the drum. Okay. The diagram shows clearly the pressure changes during the fuel combustion, fuel timing, or injector faults. At a later stage, we will be doing all the faults. And where is the diagram gone? Yeah. So this is the diagram draw card, which is taken by means of pulling the cord manually. So this is the compression point up to this point where the fuel injection takes place, and then the combustion, then it goes. TDC is somewhere here. Before the peak is the TDC, and then the expansion takes place. Okay. Why out of phase? Why is it called out of phase? If the volume on the x-axis is moved 90 degrees out of phase with the pressure, so that I have a diagram in my diary, but it is not so much of relevance. Just remember the 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 status of display on the drum is 90 degrees behind the piston. If the volume on the x-axis is moved 90 degrees out of phase with the pressure, so that the pressure reached at TDC, the volume is recorded at 90 degrees at TDC. And then the piston has reached 90 degrees after TDC. Sorry, it is after TDC. The volume recorded is that at BDC. And then when the piston has reached BDC, the volume recorded is at 90 degrees after BDC. This will amplify the horizontal plane of what is happening to the pressure in the cylinder, allowing faults to be diagnosed a little easily. So this is little display on the card is a little out of time with the movement of the piston. So that is why it is called a out of phase diagram. Now the compression card, this is the third one, is indicative of the compression pressure. Okay. The performance of the piston ring sealing is evident. Yes. Performance of piston ring sealing is evident. That means whether your piston rings are in good condition or they are leaking, it will be told by your compression card. Your integrity of the combustion chamber can be assessed. That means how good the enclosure is, whether the indicator cock is leaking, whether the seating of the air starting valve is leaking, or the exhaust valve is leaking. So any leaks will be indicated by the compression card or compression pressure. And this card is taken with the fuel cutoff. Obviously, you don't want to have the fuel cutting in to cause a combustion, because your focus is only on taking the compression card. How much compression is taking place? And it should be more or less the same for all the units. And the last card that we have is called the light spring card. Illustrates the exhaust and scavenge processes at the BDC regions. Not exactly BDC, at the near BDC regions, I will say. It is not at B, near BDC regions. That means at the lower end of the stroke. Illustrates the exhaust and scavenge process at the near BDC regions. That means near about BDC, whatever happens. It indicates choking and restriction of exhaust and inlet ports. Okay. If there is a choking, then the gas pressure will not drop to atmospheric pressure. It will still remain held up. Also, it shows the timing of the exhaust valve opening, early, normal, or late. Let's have a look at the diagram once again. No, not this. Yeah. Now you see, this is the point at which the exhaust valve opens or exhaust port. If it is a port, then this cannot change. But if it is an exhaust valve, it may open earlier or it may open later. So this variation will be indicative whether the timing is correct or not. In other words, the exhaust valve opening can also be varied to suit the whole combustion process. But in the case of a port where you have exhaust ports, there is no scope of changing this point because the port is fixed port and the opening of the port will always remain the same. So exhaust valve malfunction in terms of timing can also be studied by this diagram. Okay. Indicates the choking of the restriction of the exhaust and inlet ports, and also shows timing of exhaust valve opening, whether it is early, normal, or late. Okay, so these are the four functions. Now here I've given you the procedure to obtain indicator card or the power card to be taken during calm weather only. I think that helps in answering Rahul Kumar's question. But Rahul, you're asking the same question what another section boy had asked. Same question. That's all. There is so much of vibration, so much of movement. How we'll take the cards? No, we will not take the cards when the movement is excessive inside the ship by rolling or pitching. We will take it when the sea is calm and the ship is moving very steadily. Okay, I should have mixed that. Oh, I made a mention here. Actually, this mention I put it after he asked me the question. So this was not there before. So I put this after he has made this question. Okay. Milton Kumar Das. What is Sagar Sandesh weekly paper? Never mind. Okay. Use use protective gear like gloves, goggles, safety shoes, and proper outfit. Okay, for an examination, you can write all this, but in practice, they don't wear goggles for this. You don't need to wear goggles. Gloves, yes, I would suggest wear gloves on only one hand so you can hold that instrument. With the other hand, you get a little better sensitivity in operating the instrument. Safety shoes is a normal practice in wearing it while you're in the engine room. Proper outfit means you're wearing those boiler suits or overalls. Remember, those boiler suits should not be loose. Your sleeves should have its button in place. No jewelry, no rings, no watch, no chain around your neck. These things to be avoided at any cost. Do not wear. They will be ultimately causing you very serious injuries. So do not wear anything like this. Ring, wristwatch, kada, and then chain. Sometimes wear earrings also. Humbug. So do not wear such jewelry inside the engine room because they will be a cause for your mishap. Next is use proper spanner supplied with the instrument to open and close the attachment to the indicator cock. I shown you the diagram of the indicator instrument, that nut. It had two studs. These two studs are used to open and close that nut. And to open and close that nut, you have a special spanner. This spanner is like a pipe, a short pipe at two ends can be used, but one end is a flattened end, another end is the normal pipe. So you fit it onto the stud and rotate the whole nut. Do not try to use another spanner because you will damage that nut. Next is fix the diagram paper or card paper. Fix the card paper firmly over the drum. See, a lot of books will tell you fit the instrument in place, fit the card in place, then press the stylus and pull the cord to draw the atmospheric line. I have reservations against such a statement. I would rather have the instrument in my hand and I'll press the stylus with one thumb and pull the cord with the other hand and get the atmospheric line. What is atmospheric line? It is the atmospheric pressure acting on the top of that little piston over there. Now, if you fit that instrument on the engine, on the indicator cock, and then draw the card, there is a possibility of a small leakage from the indicator card acting on that piston. So the position of the piston and thereof of the stylus will be little different. So the atmospheric line that you draw will not really be atmospheric pressure. It will be that leak off pressure from the indicator cock. So it is best to draw that atmospheric line when you hold it in your hand. In other words, atmospheric pressure is acting on that piston to position that stylus. When you pull the cord, it will draw the real atmospheric line. So no error. But the other way, if there is a mistake in the atmospheric line, then your peak pressure is also incorrect. Your compression pressure is also incorrect. Your calculation for the power is also gone. So always draw that atmospheric line when it is in your hand. Fix the diagram paper firmly on the nut. Before connecting the instrument to the indicator cock, open the indicator cock, allow 2 or 3 firing strokes to blow out the soot and combustion residues in the cock. Pull the cord, press the stylus to draw the atmospheric line. This is what the book tells you. But I would suggest that after fitting the paper, I will have to change this. After fitting the paper on the instrument, immediately draw the atmospheric line. So this I will change the sequencing of this procedure of taking indicator card. And you can write also in the exams if you, it is better to draw the atmospheric line when the instrument is not fitted on the indicator cock to avoid any possible errors arising out of a leaking cock. That leakage may be very small. You cannot see, you cannot feel, but the pressure outlet will be there. Okay. I hope you have understood what I said. Next is fasten the instrument to the cock so that the cord is able to hook up with the piston link rod and remain taut. That means the cord must be a little tight. That means the drum will have rotated a little bit, not much. So that is why I keep saying the length of that cord is a very critical factor. That is why on the ship, what we do after we have finalized the length of the cord, we make a loop and make that loop a permanent loop. So the next time when we take the indicator card diagram, all we have to do is fit the loop immediately. We don't have to start measuring whether the cord is of the correct length. With the cord hooked up to the piston link rod, the drum will rotate back and forth in sequence with the piston reciprocation. How many times it rotates, it doesn't matter. There is no heating involved. So the drum can keep rotating. Now, when you open, next point is you be ready to take the card. Moment you open the indicator cock, the piston inside starts moving. At that time, you press the stylus and take it off again and close the indicator cock very quickly. Press the stylus gently and momentarily to etch. Etch means to scratch. To scratch the power cord diagram with a single line. Then after that, I should have written here, close indicator cock immediately. This is to avoid overheating of the instrument, because it is not only one unit that you're taking for 7, 8 units, maybe 9 units. So you cannot afford to overheat it and then wait for half an hour for it to cool down so that you can take the other one. It has to be reasonably cool to keep taking one from the other. You can't spend 3, 4 hours. Within half an hour to 45 minutes is the time limit for taking all the cards. That is the maximum time, because you don't know, suddenly outside the sea conditions will change, the current will change, the weather will change suddenly, and then everything goes haywire. Okay, remove the instrument from the indicator cock and take out the card. Allow cooling of the instrument under the engine room blower. Next is disconnect the cord. How can you? You have to disconnect the cord well before removing the instrument. This is okay. This doesn't make sense here. Anyway, you before you remove the instrument, obviously press close indicator cock immediately and uh, uh, um, uh, remove cord from link. That helps. Close indicator cock and remove the cord. That makes more sense. Remove instrument from the indicator cock and take out the card. Allow cooling of the instrument under the blower. Make sure that the instrument is not exposed to high temperature for a long time. This may affect its accuracy. Remove the hook. Turn the drum by hand to place clear form for the power diagram. Take compression pressure line with the fuel cutoff. After taking indicator cards from all the cylinders, open the instrument, clean all the parts and lubricate the same. That means all the parts will have to be cleaned before you put it back. Okay. Now, calculation of the area of the indicator diagram with the planimeter. I wish I could have made it a little bigger. How to make it bigger? Little bigger, let's make it 18, 20. Okay. Okay. calculation of the area of the indicator. Before I go into this, I will show you the diagram of the planimeter. Okay. Oh, this is not the diagram. This is a diagram that is obtained for the power card. And this is the area that needs to be calculated. This height is the peak pressure, and the length of this diagram is the value L. If you divide the area by the L, you will get the mean effective or indicated pressure. But before that, let me give you an introduction to the planimeter. The planimeter is an instrument which is kept inside the chief engineer's room. It consists of an anchor. Anchor is a cylindrical iron block. It's reasonably a little heavy. It is the size of about 4 centimeters by a diameter of 4 centimeters. This is cylindrical block, 4 centimeters by 4 centimeters, and there is a pin at the bottom. You see, what you see here is actually a drawing board, a wooden drawing board, similar to the drawing you have done in your third semester, but a smaller one, and it is there with the chief engineer. So on the drawing board, he installs this anchor with a pin in it. So the pin goes into the wood and it locks its position. On this anchor, you have an arm, this arm. So ultimately, this arm can be rotated around this point because this point is fixed onto the drawing board. So this remains in one place but is capable of swiveling, goes from side to side. And on this end of the arm, you have a rounded ball at the end of a L piece. I should have made it in this diagram only. Okay, I will make it on this diagram. And this piece fits lightly into a hole of this square box, or it is called a digital numeral display box. And it is capable of swiveling inside here. It is only locating this position. That's all. It does not do anything except locates it. And this box, it has got two wheels on the underside. One is in this axis and one is in this axis. Sorry, one is in this axis and one is in this axis. They are two at right angles to each other. Along with this, you have a digital display counter, not digital display, a numeral counter. And these are actually small wheels inside with the digits written on them. So as you keep moving this box, the right side, the unit number will keep changing. And if it moves 10 times, then the tens one will move. And then 10 times this one will move, this will be here. So it's a digital, digits are there, but it is mechanical, purely mechanical device. Maybe the modern engines will be having, or modern chief engineers will be having a battery operated digital display, electronic device, but I would still trust the mechanical ones much more. So on this box itself, there is an arm which goes on to holding a magnifying glass. This magnifying glass is quite a big glass, thick glass, and at the center there is a cross. The cross is to identify a point. Okay. So when you move this magnifying glass anywhere, this wheel will also move. As this wheel moves with respect to this arm, the digits inside will keep changing. And as it keeps changing, it records an area that it has covered. Now, under the magnifying glass, you're supposed to put in that paper, that indicator card paper. And that paper card can be held by means of a scotch tape or a pin, drawing pin. You can hold that paper in place. Now, this magnet on the card itself, on the line diagram, you make a reference point. On this reference point is where the cross of the magnifying glass will rest. And then you take the reading on the digital display and record it somewhere. Say 5621. 5621 is recorded. And then you start moving the magnifying glass along this line of the diagram completely to the end and come back to that same point what was there. Then you take a second reading of the digital display. So the difference between the earlier figure and the second figure will give you the area of that diagram. directly in millimeter squared. Okay. Once you get the diagram area of the diagram, you can close up or put up the next diagram, and then again measure the next diagram and record it on a separate register. So each unit will have a separate diagram, and these diagrams will be used for measuring the power or measuring the area inside the diagram to calculate the power for that unit. Okay, today we will keep a close for this. Okay, let's finish this page also. So unit of the final result, indicated power is, sorry, no, we cannot come here. We have to first go here or even before that. Yeah, calculation area of the, I only wanted to give you the picture of the planimeter. Just understand what is the planimeter and how it is used. We will go into the calculations again from scratch in the next class. Your new class is going to start just now. So that is why I cannot hold you up more than 11:10. It's already 11:07. But this is the planimeter, and we will go into the calculation of the area and power in the next class. Okay, that will be all for today. If you have any questions, you can ask quickly, and I'll keep it at that. No questions. Okay. Okay, that will be all for today. Remember, you prepare for your semester exam, you prepare for your uh, campus interviews, and you prepare for your existing semester classes. All right, that will be all for today.